Here is Michael Pulin. I'd like to introduce you a tandem pattern developed specifically for the event-based applications, event-based architecture utilizing microservices. In the traditional approach to the event-based applications, the initializing microservice fires an event and sends it to the intermediary event store, which in turn pushes this event to the target microservice. Another model of the event interaction between microservices called event pooling requires additional attention, and I will explain you what is the problem and how to work with it. We start with that we have two microservices, microservice 1, which fires an event 1, and microservice 2, which is interested in the event 1, and the event intermediary store between them. So the microservice 1 fires an event and places it into the event intermediary store, while the microservice 2 actually supposed to pull this event and start processing it. This is a normal situation how the pooling event communication happens. But what if something going wrong? Assume following cases. First, a failure of the store itself. This case might be quickly identified by microservice 1 because it will not be able to either set a connection with the communication with the intermediary store, or will not get acknowledgement about the firing event and something like this. So microservice 1 can quickly identify the case and inform about that support team. Second situation, when the crash happens in the network between microservice 1 and the intermediary store, or between the event store and the microservice 2. Since networks monitored very actively, any crashes like this will be quickly identified and probably even fixed. So it's not also a dead end. The dead end happens when the microservice 2 fails, crashes, or misbehaves. In this case, since microservice 1 does not know about microservice 2 and vice versa, microservice 1 never ever can be sure that the fired event 1 would reach those who might be interested in that, and that might crash the whole application. The tandem pattern comes exactly to help in this situation, addressing also that we don't know how long event 1 can survive in the intermediary store, and we need an immediate reaction to the failure of the microservice 2. Tandem pattern represents another microservice called Microservice 2 Tandem. It does exactly the same thing as Microservice 2 and connects to the event intermediary store and retrieves exactly the same events as Microservice 2. And this is a solution based on the following assumptions: that both microservices, Microservice 2 and Microservice 2 Tandem, are designed, developed, and deployed in pairs, always. That the intermediary store can handle events enough time to them to be picked up and processed by microservices, as well as the frequency of placing new events into the store can be comparable to the frequency of pulling events from the store. So how these two microservices work together, why they are the solution of the problem. Assume that microservice 2 pulls an event from the intermediary store, and before it processes the event, it looks up into its internal data store where we keep an internal queue. Internal queue is a mirror of the external queue for the events that microservice 2 is interested in. So microservice 2 picks up the latest entry into the internal queue, and if this entry is the same as just obtained event from the intermediary store, microservice 2 understands it's a duplicate and it ignores the obtained event and goes to sleep. However, if these two entries from external queue and internal queue are not the same, microservice 2 places the just obtained event into the internal queue and only then processes it and acts as designed. This internal queue data store shared between microservice 2 and microservice 2 tandem. So when the time comes and the microservice 2 is ready to work, it does the same thing. It pulls the event from the event intermediary store. Both microservices have their internal schedulers. The scheduler for microservice tandem is set in a half period later than for the microservice 2. So there is enough time between working of these two microservices for the microservice 2 to update internal queue. So when microservice 2 pulls an event from the intermediary store, it also goes to the internal queue, picks up the latest record, compares it to the just obtained event from intermediary store, and if they are the same, this event is ignored. If they are different, microservice 2 tandem places this new event at the end of the internal queue. They work this time continuously, one after another. And this is the full description of the tandem pattern. As a result, we can see that the information from microservice 1 as an event propagated through the tandem pattern to the further part of the system. What happens if microservice 2 fails, crashes? Microservice 2 tandem continues extracting events and comparing them, storing them in internal queue if it's new events, then processing them, and the whole system works from microservice 1 to microservice 2 and further, even when microservice 2 is failed. That's the major value of the tandem pattern. The benefits of that pattern and results are presented here. The tandem pattern provides a runtime failover that is very important for the crashed pooling microservice. And this increases the robustness of the whole application where these microservices work. Tandem pattern allows collecting all events that particular microservice, in this case microservice 2, is interested, and collecting them in the internal queue, which could be used for audit and for backup if it's needed. And finally, if the pooling happens more frequently to microservice 2 and microservice 2 tandem, then the new events appear in the intermediary store. The existence of the internal queue helps to prevent duplicate processing of the events, and this also increases the robustness of the system. This is all for today. I hope you might have questions or comments. Please send them to my website, and thank you very much for your time, and goodbye.